Hi, I'm Randall Heyman, a mathematics academic, and you're on one of my Corona Help playlists, which I've set up to help people during the coronavirus outbreak. So if you'd like me to make a video for you or your students, comment below this video, any of my videos, or drop me an email to coronahelpmathematics@gmail.com. And I'm trying to turn them around as quickly as I can. Okay, so Alcan and Benny have contacted me about this line in the proof of Euler's theorem. I've done a whole playlist. So there's a whole playlist on Euler's theorem, and this was one line of it. So it's been commented to me that this is similar to or comes from Lagrange's theorem, and so I thought I'd just do a video that will put people on the right track for that. The challenge here for me is not to put too much detail, otherwise we'll go on for too long. So let's put up Lagrange's theorem. The order of a subgroup divides the order of the group. I mean, I'm just writing my understanding, so I'm not getting that from a book. If you look in a book, there'll be a little bit more detail, maybe. You know, let G be a group, blah, 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 blah. That's the guts of it. So let's just write some stuff here. In the playlist on Euler's theorem, we were talking about this group. The group, it was the set X such that 1 is less than or equal to X is less than or equal to M, and the GCD of X and M is equal to 1. So that was the set, and we had multiplication, and here multiplication is multiplication modulo M. We saw that's a group, and actually it has order. Order was equal to the Euler-totient function of M. Okay, so now what's a subgroup? A subgroup, we say here, subgroup. What's a subgroup? A subgroup is really a subset of a group that is in it itself is a group. So subgroup, example, the integers under the operation addition are a subset of the reals under addition. We use this symbol here. Once again, this is a problem for students that we use the same symbol here for groups to mean a subgroup as we do for less than or equal to with integers, which makes life confusing, but that's the way it is, I'm afraid. So that's what a subgroup is, and what it's saying is that the order of the subgroup always divides the order of the group. And I think if you go back to one of the videos in the Euler's theorem playlist, you'll see I go through where M equals, I think we did M equals, let me just think. I think we did M equals 10. And I think we saw that the orders, no, that was the elements, wasn't it? So we can't do that, no. Okay, so that's the first thing that we need. And then the other thing that we need is, if you work back from this, the order of an element of a group divides the order of the group. And Lagrange's theorem says the order of a subgroup divides the order of the group. Well, then what we need is another theorem or lemma, whatever you want to call it, which says that an element of a group, well, actually, let's do it this way. I suppose it might help if I actually just took stuff out of books, but anyway. The group formed by repeated operations on an element of a group is a subgroup. So let's just write, I think, as I said in 1.1, I previously did 10. The group is was 1, 2, 3. These are the ones that are co-prime to 10. 1, 3, 7, and 9. And let's take the element 9, and then we'll repeat. We'll do. Oh, sorry, I should put the operation there. Let's patch that up. So 9 is an element, and then we go 9 times 9, which is equal to 81, which is equivalent to 1 modulo 10. So actually, let me now go over to here where there's a bit more room. So what I'm saying is 9 is an element of that group, and then if we had 9 and then we went 9 to 1, and then once we get to 1, if we keep going, 1 times 9 is 9, 9 times 9 is 1. So these are the only two elements. And what we are saying is that this is itself it's a subgroup of, let's call that G there. So it's it is a subgroup of G. Okay, so here we've shown that it's a subgroup. Here we've shown that the order of any subgroup divides the order of the group. And so here we conclude that the order of an element of a group divides the order of the group. So I hope that's sort of set you up if you want to explore more about this line in Euler's theorem further. But if you want to get into it more, you'll need to understand subgroups. And to do that, you're probably going to need to understand, well, to understand this line, you're going to need subgroups, plus you're also probably going to have to understand cosets. And then you can work through the proofs of this and this if you wish to. Okay, any comments on any of this or any other branch of mathematics, just comment below any of my videos or drop me an email.